There are some methods that you can use to do the vector addition, but now the first method of first addition that I would like to discuss with you is called parallelogram method. This is the easiest one. So first let me show you a parallelogram. This is a two-dimensional object that has two pairs of parallel sides. So this is the first pair of parallel sides, and then this is the second pair of parallel sides. So remember, when you draw a parallelogram, that must satisfy this requirement. So now if you have two vectors, let's say this is the first vector A and this is the second vector B. Now how do we add these two vectors A plus B? Now I will show you how to do the vector addition using this method. So first we have to put their tail together at the same point here. So you can move a vector, but keep in mind that the vector should parallel and the magnitude should be the same. So you can move a vector, but it must be parallel and then the magnitude should be the same. So now I'll put the vector B here. Again, this one should be parallel with the original one, and also the magnitude should be the same. So when we already put their tail at the same point here, now we can make a parallelogram using these two vectors. So keep in mind that you must have two pairs of parallel sides. Like this. And the diagonal of this parallelogram, this diagonal, that's the resultant of vector A and B. Now we have vector P and Q. So how do we add these two vectors using the parallelogram method? So first we put their tail at the same point here, and let me move this vector, and this must be parallel with the original vector and has the same magnitude. And then vector Q here, like this, and the magnitude is the same here. And now we will make parallelogram. Keep in mind that this is the parallel line here, and then so the diagonal of this parallelogram starting from their tail here and ending at this point, this is the resultant of P and Q. Probably now you are asking me how we do the subtraction, let's say a minus b. Now we have vector a and vector b here. Well, let me show you that a minus b here is actually the same to a plus minus b. So let me show you minus b here. If we have vector b like this, the minus b vector is just a vector with the opposite direction from b. So this is minus b vector. But the magnitude of these two vectors, they are the same in the magnitude. So now we want to add a plus minus b here, and we will use the same technique here. So first we will move vector a, make sure that it's still parallel, and then vector minus b, and now we will make a parallelogram. So this is a minus b vector. Now let's do for minus a minus b. And you already know that this is the same, like minus a plus minus b. So if we have two vector a and b like this, first let's draw minus a vector. So minus a vector is just a vector that has an opposite direction from vector a, but the magnitude is the same. Also minus b vector here. So now we just add these two vectors, minus a and minus b, together. This is minus a, and you need to make sure that this is parallel with that one, and that's minus b. So the parallelogram here, and this is minus a minus b. Or actually you can also think like this: minus a minus b is equal to minus a plus b. So now if we add a plus b, let's see, this is a, and then this is b, now we get a plus b. So minus a plus b is just the vector that has opposite direction from a plus b vector. And this is the same with this one. The second method of vector addition that I would like to discuss with you is the polygon method. So we have vector a and vector b like this. Now we want to add them. So we start with the first vector. Let's draw vector A. And make sure that this vector is parallel with the original one, but the magnitude is the same. So when we finish with the first vector, we now continue with the second vector. So from the head of vector A, we draw the second vector. This is vector B, and make sure that this vector is parallel with the original one. So the resultant of A plus B here is starting from starting point A, and it ends up B here. So this is the A plus B. Now, if we have more than two vectors, let's say we have A, B, and also the third one, C, it looks that the polygon method is easier for us. And now we can find the A plus B plus C. We start with A and then we continue with B, and now we continue with the third one, C. So the result of our vector addition is this one. Now you are probably asking me, if we have two vectors, let's say vector C and D, which has a magnitude, let's say this is 6 centimeter and then this is 8 centimeter, and the angle between those vectors is 60 degree. Now, how do we get the magnitude of C plus D? Well, the easiest thing that you may think of is that you can draw this vector first, for example using the parallelogram, and then you get the diagonal like this, and you measure with a ruler like this, and then you get the length of C plus D. But of course this is not precise, this is not very accurate, and now we will do the different thing to get the magnitude of C plus D. Well, basically if you have two vectors here and you want to get the magnitude of the resultant, let's say you have vector A that has a magnitude small a, and then B, small b, and the angle between those vectors is, let's say, theta. And now if we draw a parallelogram, the diagonal of this parallelogram is A plus B, and let's call the magnitude of this vector is small c. Now you can always derive how to get the magnitude of c, but I'll just go directly that the magnitude of c here is the square root of a square plus b square plus 2 times a times b times cosine theta. So now let's move back to our previous problem here. If you want to get the magnitude of this c plus d, let's call that e. So by using that formula, we can find the magnitude of e. So here is square root of 6 square plus 8 square plus 2 times 6 times 8 times cosine. The angle here is 60. Now we can calculate this. Cosine 60 is 1/2, so this cancel out, and then we will end up with 36, 64 plus 48, and then we get here is square root of 148. So the magnitude of factor e here, or small e, is square root of 148, or it's around 12.16 centimeter. So now in the previous problem we have factor c and factor d. Now let us calculate or find the magnitude of c minus d. And you already know actually that c minus d is the same c plus minus d. And if this is factor d, the minus d is just the opposite direction, but the magnitude is the same, 8 centimeter. So this is minus d. And now we will add minus d and factor c here. And this is 8 centimeter, 6 centimeter, so let's call this factor g, and the magnitude of g here is small g. So but be careful, now the angle between factor c and minus d is not 60 degree, because this is 60, but you can find this angle, and that's 120. So if we want to calculate the magnitude of factor g here, is equal to square root of 6 square plus 8 square plus 2 times 6 times 8 times cosine 120 degree. And this is minus 1/2. So if you calculate the value, this will be 36 plus 64 minus 48, or you get square root of 52. And if you calculate the value, that will be 7.21 centimeter.